Cheers. And dim 1. All right, morning everyone. You settle, please. Hello, it's time to start. Okay, first thing, let's tidy up some housekeeping stuff. Been asked to show this. Probably any lectures you got today are going to show this, unless they're not doing what Bev asked them to do. But I'm a good boy. There's a message asking if anyone wants to be on the board of ELFS, as in Enabling Program English Language and Foundation Studies Centre. They take some students, and it's there's 3 times a year they meet, and it's to represent students in it. I can understand the whole thing sounding like, well, they haven't got anyone to volunteer yet, hence we've got to show it again. You're probably thinking, why? Why hasn't anyone volunteered? It sounds fun. It does come with a certificate, and certificates about this sort of stuff do look pretty good on CVs. So apart from the fun of meetings and having your say, it does look pretty good when you're going for a job or a scholarship or something and say, I was on the board of ELFS as a student representative for 2012. Yeah, those sort of things help. Anyway, so that's just saying if you are interested at all, New Step office. The paperwork's there. Just see them there and ask about nominating for being a member on the board. Before that, other housekeeping. Just a reminder, I've put the email out, but so we're 1 day short this week. If your tute's on Friday, you would have or should have gotten an email saying, hey, your tute's moved because Friday doesn't exist this week, or it does, just in a much better way, but there's no uni. So your tute's moved, some people can't make those tutes, email me and slot into some other tute. Okay, it's no big deal. So yeah, class goes on as normal. Next week, we're all off, okay? When we do come back in week 5, we've got the class tests. So fairly major one, 15%. It would be right now, would be starting as you speak, about 10 past. So remember main things, yeah, it's right here. It's not a tute test, it's here. So week 5, we do that. We don't do a quiz in week 5. You do one or the other. There's a quiz in the tute, or we have a major test in week 5 and 10. It'll be on 3 weeks of stuff. Question 1, 2, 3 will be weeks 1, 2, 3. So all the non-calc stuff. I put a revision paper in course materials on Blackboard on the weekend. There's an announcement pointing to it. That's just a paper that's just like ours, really. It's not just numbers change. It's not that lame. But it is, you know, there's only so many questions you can ask. And it's going to be a fairly predictable exam. Not nasty ones like that'll get them. No, just, you know, put this in scientific notation, round this to 2 significant figures. You know, all just really standard stuff. So worth 15%. Definitely worth doing the best you can in. It's 50 minutes, and then there's still a lecture. So we'll do it from about now to about 10 o'clock, have a 10-minute break, and then still have a half lecture, okay? Small content, but there'll still be some lecture. Any questions on that stuff at all? Anyone unsure? No? Okay, so yeah, that's really, yeah. Just don't forget about that. Have a good holiday, but don't forget we come back to that. Okay, can we settle a bit more, please? This is a fairly quick lecture if we're able to get through without too many interruptions. Okay, can we please settle a bit more? All right. Calculator stuff, these first slides, not going through bit by bit, it's in the course notes, and most of you will go, yeah, look, I know how to use my calculator. Just want to point out a few things. Can we still stop the conversations, please? Can we start to do that thing? Might have to do it from now on. I hate doing it, but going to start saying, you know, if you want to talk, it's okay, but leave. I hate doing the chuck out thing. I really do everything I can to not do it, but please have a listen. or leave if you want to talk. That's fine too. With the calcs, you got a calc, you know how to use a calc. Okay. Couple of keys. This key. A lot of calcs have this exp key, and a lot of us haven't bothered to use it. That's fine, and it's still not essential, but it's the same as the times 10 to the key on back on here on the Casio. This times 10 to the key, it's the same as this exp key. So if I'm putting this in the calculator, 2.3 by 10 to the minus 5, I can do that by 2.3 exp minus 5. Okay? It's a pretty minor shortcut, but that's what it is. Okay? That means times 10 to the. So have a look at that when you're doing stuff, you know, scientific notation in the calc. Maybe you want to do that. Maybe you just want to go times 10 to the and think, look, who really cares? Another thing to watch, which gets people caught out a lot, inputting minus 3 into the calc. Some calcs will accept the minus key and then 3. Some will insist it's this minus key and then 3. Just check. I don't remember which ones. I know this one's fine with using the big minus key, but some of them, like, I think this one doesn't, but just check. So if I'm doing minus 3 plus minus 6, I'd have to do plus minus 6. I'd rather just say, look, I know a plus minus is a minus. So don't rely fully on the calc. If you've got a fairly simple problem, putting every step into the calc is just increasing the risk of making a mistake. See it constantly, 3 times 1, that'll all go on the calc. We know what it is, so I'm just saying, engage a bit with it, just put in the calc stuff that it needs to do. But the times 1, the plus 0, all that sort of stuff, every keystroke potential for mistakes. It's funny, when I put a calculator question, and will again, into exams, I see it as sort of like, or I used to see it as, well, there's a gift mark. You know, everyone can use a calculator. You'd be amazed at just, yeah, no, it's not a gift mark. How many of us will make mistakes? The old 2 plus 3 on 7. How many mistakes? Because people will type it in. 2 plus 3 on 7, which is 2 plus 3 sevenths. But it was 2 plus 3. Okay, so just be careful of that sort of stuff. The brackets. Well, don't put in 2 plus 3. Go 5. We can do it. This calculator, well, it's too easy. You see it. Okay? It's hard to make those mistakes on this calculator. But on the others, it's just the warning. Don't take it for granted. Just check a few and make sure you're okay with your calc. Apart from that, let's just talk about the memory buttons and that. I'm not going to go through them. So, estimation. Don't expect to be tested on estimation, really. Okay, it's more a tool than a thing where saying, hey, you need to know this. And it's more potentially maybe common sense. Just about, like there's an example in there, you're at a restaurant trying to work out the bill. Okay, 9 friends, 175.50. Someone looks at you. You're doing maths at uni, you work it out. As I get when I'm out, they say, hey, you're the maths genius, you work it out. But I'm drunk. You need techniques. Just rounding off to one significant figure is all estimation is saying. 1 or 2, it doesn't really matter, it depends what sort of numbers they're forming. If I just wanted to go one significant figure here, I'd say, all right, 175, look, I could call that 200, but that's rounding a bit too much. Yeah, I'd call it 180 bucks. Divide by 9, instantly I know, look, we're about the $20 mark, and the exact answer is 1950. Now, I'm not saying let's just get, approximate answers on our tests. I'm just saying this is all about not trusting the calculator fully. If you're putting 175.50 divided by 9 into the calculator and it spits out $70, don't believe it, okay? We make mistakes. It's just going on a question like this, I'll be going, I'm about to go to the calc, but hey, I expect the answer to be about 20. When 1950 pops up, I go, that's fine. I move on, I've left that question, I don't even proofread it later. It's done. It's just having an idea of what to expect. And of course, sometimes if it's some big calculator thing, oh, you're just going to trust it. Understood. But it's just a very generalized thing. This one, okay, someone's saying $421.30 per fortnight. What's a fortnight? 2 weeks, bit of an old-fashioned term, but people still seem to know it. So $421.30 every 2 weeks. How much do I earn in 1 year? You know, really, we want to multiply that by 26. There's 26 fortnights in a year. But $421.30 times 26, not the nicest one to do in your head. So here we'll just be saying, look, $420, how much a week? I'll just divide it by 2 to get it per week. And then I'll times it by, there's about 50 weeks a year. Okay, 52. But approximate. 210 times a 50, I'll probably round that to 200 times 50 and say, look, it's about $10,000 a year that will do. So that's all the estimation's about. I'll restate again. I'm talking about doing things in your head and that. Yes, we're into calc zone. The only non-calculated things we have left is this week's quiz, because it's on last week's stuff. And of course, the class test in week 5 is all non-calc. After this week's quiz and week 5 test, we won't mention non-calc again. All right? We have it back for good. Even if there's a question in an exam that says, do this, like in the final exam. The final exam in halfway through the year, we'll still test you on weeks 1, 2, and 3 content. Okay? It tests you on everything. And it might say, do this fraction question without using a calculator. So you've got to show your steps. But of course, you know, well, hopefully you'll still use a calculator to check your answer. Okay? But yeah, there are still questions that will require you to understand what's going on. But you'll always have it. Again, 98.6 cents a litre. When was that? That many litres of petrol. The obvious round off there, I'd be calling it, yeah, it's $1. I'm getting about 30 litres. $30. Okay. So there's estimation. This slide and the thing in the notes is just, once again, just looking at this question and the calculator. So you've gone the calc. I've put in 27.9 by 3.24. The calculator said 90.396. Do I say, is that about right? Yeah. 30 by 3. Yep, that was fine. I'm happy with that. I didn't make a mistake. 684 by 53. I don't know. I might just call it, if I'm going to one significant figure, 684 would be just 700. 53 would be 50. 700 times 50. I think it was 7 times 5 is 35. 100, got 2 zeros, 1 0 here, about 35,000. 36,252? Yeah, absolutely. 4981 divided by 46. I would hope I could look at that and say, no, look, there's 2 extra places there. I did that lock. That was nice of me, sorry. That was my bad. That's about 5,000 divided by 50. My answer is going to be around the 100 mark, not 10. So clearly there, I'd made a mistake, okay? I didn't press the 1 or something. Maybe I just did 498 divided by 46. But I'm not just trusting the answer. I knew it was going to be about 100. Again, the next one. Well, it's something like 900 divided by 3. 861, 289. So expect 300-ish. Yep, that was fine. And the last one, not really. I wouldn't really be doing a 3-parter in my head to check it. It's really the others, okay? But yeah, I could. 720 on 6 is about the 120 mark. Yep, fine with that. So that's enough of the estimation. And that's just, yeah. Whole point of that was, yeah, not blindly trusting the calc. I'll put the rock back now. I think he's gone away. Okay, simple interest. You've probably done simple interest, you've probably done compound interest. And compound interest is what really happens. Okay, compound interest, we earn interest on our interest every pretty much day. At the end of the day, you know, computers are working out, you know, this much interest, it goes back in the account, so your account grows more and more. Simple is, as it says, just a simple calc. It doesn't matter if I put money in for a year, simple interest doesn't matter whether you calculate monthly, per year, whatever. It's not putting interest back in the account, okay? It's just saying it's in for a block, it earns its interest, there's no compounding, no money going in, so you earn money off the interest. Just keeping it simple. Compound interest, well, we don't do this semester. I equals PRN. That's our formula. It's not a provided one, but once you've used it a few times, it's a pretty simple formula as well. You may, in the past, have been given the formula I or even SI equals PRN on 100. Same formula. The only difference is that one's assuming you're going to put your rate in as a percentage. So it needs dividing by 100. Without writing 100, we're assuming you're going to stick your rate in as a fraction or decimal. So we're just going to stick with interest equals PRN. Okay? So the P is for principal, the amount you're invested, just the amount of money. Now we're saying interest rate per period, a number of periods. So it doesn't say per year or per month. You can use whatever you want, as long as they're the same. If you get an interest rate per year, then maybe do it per years. Interest rate per month, convert everything to months. As long as they're the same time periods, it doesn't matter. So let's move on. Here's a principal of $3,000. 3% per annum, so meaning per year. Calculate the interest earned each year. Well, that's one question. And also the interest earned over 12 years. So we've got two questions. Firstly, the interest per year, well, it's just I equals PRN. Also notice it only calculates the interest, not the amount that's in the account at the end, like the compound interest formula does. Just purely works out the interest you earned. So the principal is a $3,000. The rate is 3%, which, as I'm saying, put it in as a fraction or a decimal. So you can put it in as 3 on 100, or maybe put it in as 0.03. Just don't put in just the number 3, okay? It's going to be 100 times too big. And then, since it's per year, I just want n equals 1 year, just working out how much interest over 1 year. These slides were written because I only just grabbed these out of, these were in last week, used to be. So it's written as if we don't have a calculator. We do, so it doesn't matter, but it's not bad practice. We're going to do it as if we didn't have a calc. So there's the 3,000, there's the rate, 3 on 100, 3%, 1 year. I can write them that way, as any whole number can be over 1, just to make sure that we're cancelling things correctly. I can take 2 zeros off top and bottom. Now I've only got 1 by 1 by 1 on the bottom and 30 by 3 by 1. It all came down to $90 fairly simply. So fractions are a nice way to go with these. But as I said, you've got calcs now. So there's per year. So if it wants it over 12 years, I'll just times that by 12. Since there's no compound, it's just simple. If it's that per year, it's 12 of that. Look at that in the formula. Well, it's just same old. I equals PRN. The only thing is n has changed to 12. So it becomes 90 by 12, 1,080. So simple interest is really straightforward. It's all about just making sure you can convert your time periods. Here's one that needs conversion. I've got a % per annum, but I've got 8 months. If we were doing compound interest, if it was compounded monthly, we were forced, okay, you're going months. That's it. In this time, it doesn't matter. We can either convert 6% to per month or 8 months to so many years. If it's 6% per annum, how much interest would it be per month? What would I do to it? Yeah, divide by 12? Yep. Because if you're going to, over the whole year, you'll earn 6%. Well, if I'm only going to do a 12th of a year, which is a month, I'll get a 12th of the interest. It's 6 on 12% per month. In other words, 0.5% a month. Okay, so per year or per annum to per month, divide by 12. We always knew it was going to be something to do with 12. It's not times by 12. I'm not going to earn 12 times a year of interest in 1 month. No, it's obviously the other way. How do I convert from months to years? 8 months, it's only a partial fraction of a year. It's the same conversion. Divide 12. It's 8/12ths of a year. Okay? If a year is 12 months and we're only looking at 8 months, I'm looking at 8 from 12. 8/12ths, otherwise I could divide by 4, 2/3 of a year. Okay, so either way, you'll either use 6% per annum for 2/3 of a year, or use 0.5% per month for 8 months. same answer. What way have I gone here? Probably both. Per month or per year? So first it's looked at, if we did per month, once again, there we were, we divided by 12. So I already did that. It was 0.5% per month, which you can also write as 1 on 200. That's not essential, but if I've got 0.5%, and I'll draw that as a fraction, that's saying I've got a half divided by 100, because any percent needs to be divided by 100. That's a half times 1 on 100, which is 1 on 200. Again, those conversions, we're going to do the calc anyway. 8 months, so it all subs in. Here I'm doing it manually. Okay, cancellations, but I get 200. There's no real set, easier way to go that you should do this or you should do that. Either way, I was going to divide a number by 12. Which number? Which should it really matter? If I went per year, well, I stuck with 6% per year, but I converted my 8 months to 8 on 12. And I think I didn't cancel here, I just left it. I went 8 on 12, that's fine, that's a fraction. Stick it in. Put them over 1, or put it over 1. Take off some zeros. There's 1 6 there, there's 2 6s there. I've got a 2 on the bottom and 8 on the top, so I've got a single 2 there, and I've got 4 2s up the top. It all ends up with 1 by 1 by 1 on the bottom, 50 by 1 by 4, 200. Obviously just saying, who cares which way we went, as long as we divided by 12, not times by 12. So there's one, and it's back to, there's just no tricks here. It says 3 years. It says 10% per annum. We could probably do it without our formula, just say, well, what's 10% of $550? Oh, sorry. What's 10% of $5,500? It's $550. 3 years of it, 3 times 550. But straight to the formula, I equals PRN. I've got $5,500 times a rate, which I'm remembering, 10%, and times 3 years. Okay, so I'm going to put that over 1 and that over 1, lose 2 zeros here, lose 2 zeros here. So that's 55 by 10, which is 550 times 3, which is 1650. All right, so there's a straightforward simple interest one. So hopefully you're looking at this going, yeah, this is nice marks, especially with a calc. Here, okay, 6% per annum, 4 months, same as before. Let's make a call. I might convert the months. I just want to write 6 on 100. I don't want that issue confused. I'm going to leave the percentages alone and convert the other. And if I'm going to convert to per year, per annum, well, I'll convert this to per annum. 4 months is a third of a year. Yeah, there's 3 lots of 4 months. Okay, that's all good. My interest is P, 1,000, times R, 6%, which I'll always write like that, or 0.06, times N, which is number of terms. The terms is a third in this case. So 1,000 times 6 on 100 times a third. Note with this, whether you do or don't, put the units in there. It doesn't matter. No. It's 1,000. Dick. Dolt. Troublemaker. No, thank you. I do want these things pointed out, but now you've wrecked it. So I've got 1,100 times that. I'd cancel some zeros if I could. What? Do you feel good about yourself? No, sorry. I do appreciate it. Okay, picture a 1 there. So I've got 2 zeros can go off the bottom, off the top. I've got a 6 at the top and a 3 there, so I can cancel the 3 to a 1 and the 6 to a 2. So I'd end up with 11 times 2 times 1. Okay, which is 22. Oh, it's trouble. That one and that. Okay. And we're back. So we had our 1100 times our rate times our 4/12, which we'd already brought down to a third of a year. 6% per year, a third of a year. 2 zeros gone, 2 zeros gone. A 3 on the bottom, there's one of them, and there's two of them, so I end up with 22. I got there. Okay. Next one. So the per quarter, there's one mistake which happens all the time in per quarter. It's not in this. I should have put an example in. You can tell, okay, a quarter, it's clearly related to number 4, and yeah, it's just a quarter of a year. Get a year, halve it, quarter. There's obviously 4 quarters in a year. How many months in a quarter? 3. Good. What often happens is 4 is just off-putting. Say, how many months in a quarter? 4. No. Just lock it in. It's just so easy to do. It happens constantly. But no. 4 quarters, half the year, you got 6 and 6. Half them, you got 3, 3, 3, 3. Okay. But in this case, what's our conversion? Years and quarters. So again, I'm going to decide to leave my percentage alone. I just want to write it 3 on 100. I'm going to convert the other. So I want to convert 1.5 years to something quarters. How many quarter years would be in 1.5 years? 6. Beautiful. 4 quarters in the 1 year, 2 quarters in half a year. Great. And then once you've done that conversion, that was the only, difficult bit, just making sure we get that right. PRN. 600. Oh, what I was about to say before, I was pointing at the dollar sign. Whether you do or don't put the units into these things, it doesn't matter. I remember being told at school, you've got to put the units in, and then, or if you're going to put it back in at the end, you've got to write a sentence, therefore the interest is. No, just, if you want to go through that units and stick the units on at the end, it's fine, okay? Whether you do or don't is not an issue. That times a rate of 3% per quarter times 6 quarters. I'll do that. The only thing I've got to cancel is 100. So those 2 zeros and those 2 zeros, I end up with 6 3s are 18. So I've got an 18 by 6. That gives me 108, and it's dollars. What have I done wrong? If I walk away from that question now, what have I done wrong? Yeah. I didn't read the question. I just went through and went, oh, yep, I know this. Especially if it was multiple choice, and I saw 108 and went, I'm done. All the hard work for nothing, because the question said calculate the value of the investment after that. So it's saying, give me the total. Okay, it's pretty minor, but of course it's either half a mark on a written or the full mark on a multi. So therefore, I've got to get my 108 plus my initial amount, and the investment is now worth $708. Minor, but of course matters. So just be careful on the reading of the question in these. Interest or total. Okay. On a ratio. The rest of today keeps dealing with ratios. Scales on a map, scale on an enlargement, zooming on a photocopier, all about ratios. And a good part of it's like fractions anyway. So we've already done, like simplification of a ratio. If we learn how to simplify a fraction, looking for the highest common factors, we're already done. This initial bit, don't worry too much about, I want to change these notes actually. There's a little bit too much going on about how a ratio is like a fraction. A bit overboard. But it is true, a ratio A to B is like saying A on B. If I say the ratio of dark-haired people to light-haired people in this room was 2 to 1, DL. Okay, That's saying for every 2 dark-haired people in the room, there's 1 light-haired person. Okay, it's a ratio. It's not telling you how many people are in the room. It's just saying for every 3 people, on average, I've got 2 dark, 1 light. Okay. In terms of fraction, 2 to 1 is equal to 2 on 1. That's like saying, what's the 2 on 1 saying? It's saying there are twice as many dark-haired people as light-haired people. Okay, so it's just got a relationship there. As a ratio, it just talks about the left part and the right part. As a fraction, it talks about the comparison of left and right. And there is twice. The left is twice as much as the right. If we have 5 kilos of cement and 10 kilos of sand, okay, the ratio is 5 to 10. Fair enough. That can also be written, we see on the next slide, but I'd rather say it here. A ratio of 5 to 10 can be cancelled like a fraction. Because 5 to 10 is like 5 on 10, and as a fraction, we'd call that a half. Yep, we can do the same. A ratio of 5 to 10 is the same as a ratio of 1 to 2. 5 kilos of cement, give me 10 kilos of sand. 1 kilo of cement, give me 2 kilos of sand. So again, the ratio is not about what are the numbers, it's just purely a comparison between the two. And when I look at it as a fraction, it says the cement was half the amount of the sand. A cordial and water situation. Well, the ratio of cordial to water is, 20 to 100. If we read that as a fraction, we're saying it's a fifth, or cordial, there's a fifth an amount of cordial compared to water. So, I'm not saying a total, I'm not saying in this volume a fifth of it is cordial. I mean, what fraction of this is cordial? If someone said they made up this mixture, the 20 mils of cordial is purely the coloured concentrate. 100 mils of pure water went in. And this is off topic a little bit, but if someone said what actual percent, this is more week 3 stuff, what percent of this mixture is cordial, that answer is not a fifth. If we do a percent, I'll be saying the percent cordial is equal to the amount of cordial, which is 20 mils, but what would I divide by? I mean, I want to divide by the total. Whenever you're talking about, here's a mixture, what percent of that's cordial, I want to compare the amount of cordial to the total. Okay? So it's off topic from this. This is more like, not hinting as such, but just prepping for week 5. Anytime you do a total thing, what percent of the total, remember to put the total on the bottom. And a question like this, of course, would be very easy to go 20 on 100. But 100 isn't the total, 120 is the total. So watch things like that. And also I'd write times 100. Because if it said percent, I want it times 100. The mils aren't doing anything. I can cancel a 0 and a 0. I've got a 1, 2, and 6 2s. 1, 6 times 100. Well, I'll do that to the side. I might convert my 1 6 to a decimal. Remember, if you ever want a fraction to a decimal, you can always do this. 6 is into 1, nothing. 6 is into 10, goes once with 4. 6 is into 40, 6 with 4, 6 with 4. Okay, so if I had 0.16 repeater and times it by 100, then it moves. So if I had this number and times it by 100, the whole thing was actually 16.7% cordial. There's a tangent. I didn't mean to go there. Okay, it's got nothing to do with ratios, but there's a percent question. And I haven't written the week 5 test yet, so that could be a good question. Interesting. Okay. Here, once again, is just saying a simple form of a ratio. Treat it like a fraction. Do whatever you want to one side as long as you do it to the other under multiplication or division. Don't add 2 to the left and add 2 to the right. It doesn't work that way. Just think of it as a fraction. Once again, the 20 to 100, that's a ratio of 1 to 5. It's like the cordial contains 6 parts. 1 part of it is cordial, 5 parts of it is water. The total, there are 6 parts. Okay. These are just some conversions. Ratio problems are all often word problems. And it's easy to get them the exact opposite way around. Josh earns twice as much as Tim. As to which goes first, Josh or Tim? Well, that doesn't matter. You're setting it up. Josh, then Tim. You just want to make sure people will either write 2 to 1 or 1 to 2. Just confirm. Josh earns twice as much as Tim. So for every $2 Josh gets, Tim only gets 1. That's correct. Okay, Josh to Tim, 2 to 1. No problem there. In a childcare centre, there are 2 staff for every 7 children. Staff, children, 2 was for staff, 7 was for children. All good, we've got it right. And it's in its simplest form, 2 to 1 and 2 to 7. There was nothing to simplify that down to. The next one, Mary's car was 1/3 the cost of Jan's car. So I've gone Mary, then Jan, and said Mary's car was 1/3 the cost of Jan. So Mary's was the cheaper one. $1/3 of $1, for every third of $1 spent on Mary's car, Jan spent $1 on hers. There's nothing wrong with a ratio of 1/3 to 1. But if I want it in its simplest form is whole numbers. And the easiest way to do that is multiply by 3. So I'm looking at a third, saying if I times a third by 3, it's just a 1. So 1 to 3. Again, that is not a wrong ratio. That is just simplest form. Okay? Again, this one's not a wrong ratio. It's just not in its simplest form. Luke earns 2.5 times more than he did 10 years ago. So I'm looking at a comparison between Luke now and Luke then. So Luke now earns $2.50 for every $1 he used to earn. A quick way to make that whole is just times 2 on each side. And Australian dollar one, that's pretty common. It's saying the Australian dollar, as in one of them, is worth 98 cents. So it's a ratio of 1 to 0.98, same as saying 100 to 98, which in its simplest form, since they're both even, we could have halved them. So there's some, common sort of ratio stuff. Need some examples. I know this one's already in the notes. But the length of a rectangular room is 5.95 metres, the width is 3.5. Express the dimensions as a ratio. There's no set order here. Length to width, width to length, whatever you want to write, as long as your numbers in the same order. So there was a length of 5.95 and a width of 3.5. Great, we've got the right order. We don't want them to be decimals because even though it just says that, the working is taking it to simplest form. I'll make sure they're the same metres. If it gave me the length of this centimetres and width of this metres, I'll convert them to the same before I try to get into simplest form. Okay? But no, they were the same. What I want to do now is just like the decimals and the division. If I wanted this number whole, I can see I want 2 move into the decimal place. In other words, times it by 100. Fine, but do it to this side as well. Okay, so it becomes 595 to 350. I times by 100 on both sides. 595 to 350. Now I want to look for any common factors. So if I could find a big one, great. But at the moment, what's jumping out to me, I'll look at the 5s. Okay, I can see 5 going into each of them. So I might do some upside down division here and say 1 5 there, there's 1 5 there with 4 left over. 9 5s are 45. Do the same here. 5s into that, 7 5s are 35. Then I'll look at 119 and 70 and be trying to find divisors there. I think we'll find, 7 goes into both. Hardly jumps out. So that would actually be a nasty one, but I'll add a point to that in a sec. 7s into 11 goes 1 with 4 left over. 7s into 49 is 7. 7s into 70 goes 10. All right, I've got it down. 17 to 10. But as we said, we've got the calculators here. If I'd gone to my calculator and said 5.95 over 3.5, if you're in fraction mode, a lot of the calculators spit out in fraction form. It might have spat out that. So note this. Depends what calculator you got, and you may not even want this info. But ratios are simplified by the calculator as well. Just we're used to, we know if I put 5 on 10 in a calculator, it'll put a half on the screen. Same thing here. It might put 1 7/10, but you can convert it to improper. shift and then the fraction key converts like that. So it tells you 595 on 3.5 is the same as 17 on 10. So it's a nice effort. Even if it was a question that said, show you're working, it's a nice check. So fractions in the calculator and ratios, it's worth doing. Again, we got cake to sugar in ratios here. All right, ratio of volume of sugar to volume of flour. Okay, so volume of flour was 3/4, so I'll put that second. Volume of sugar was the first one. 1/2 to 3/4, same as in the fractions topic. If we wanted to compare fractions, we had to have the same denominator. It's not easy to compare the size of 1/2 and 3/4. It's like the question, which one's bigger? So we'll find a common denominator, and 4 was great here. Okay, so I left this one alone, but I said 1/2 times top and bottom by 2. Yeah, that's 2 on 4. Now, if I've got a ratio of 2 on 4 to 3 on 4, it's like saying, put in 2 of these and put in 3 of these. Who cares what the these are? It's a ratio of 2 to 3. Once your denominators are the same, 2/4 or 3/4, it's still saying, give me 2 parts of them and 3 parts of them. So any ratios in terms of fractions, give them the same denominator, and then we don't need the denominators anymore. It's just a ratio of 2 to 3. So the ratio topic is going to test our decimals. It's going to test our fractions. And our reading skills. There's a lot of ratio problems with tricks, not intentional tricks. It just depends on the word of the question. Sometimes there's normally 2 parts. Sometimes 3 parts to a ratio. Can be more. Here, we're talking about there are 24 females and 20 males. But sometimes you'll get given the info. There are 24 females and 60 people. Okay? So you've got to do a subtraction. Just make sure you read the question and see, is this just straightforward, or do I have to do a subtraction here? This question is just straightforward. There is no trap here. Females to males. As long as I get my numbers in the same order as the letters I've defined, it's just 24 to 20. What would be my highest common factor to take out? A 4. 4 looks good. They've both got 4s in them. There's 6 4s there, and there's 5 4s there. Ratio of females to males is 6 to 5. Okay? It was like simplifying an improper fraction. 6 on 5. What do I do to answer the next question? Yep, that's it. That's just purely showing it doesn't matter. There's no set order here. The ratio of males to females would be 5 to 6. Because all that statement says is for every 6 females, there's 5 males. I could make all these groups of 11. In each group of 11, there'll be 6 females and 5 males. Order in which doesn't matter. Next, simplify that. So it's just straight simplification. There's a few common factors between an 8 and a 32. It's the biggest one. 4, what's the next step up? Yep. Again, it doesn't matter. If you're simplifying 8 to 32 and just going to use the tactic, hang on, that's even, I can halve them. I'll halve them again. I'll halve them again. No problem. It's the ratio 1 to 4. If you notice the 8, fine. There's 1 8 there and there's 4 8s there. Either way, yep, 1 to 4. Sometimes the highest common factor, or any common factor, can be hard to see. 7. Okay. So if we know our 7 times tables, we can see there's 5 of them there, but there's 12 of them there. So yep, 5 to 12. We look at 5 to 12 and look for any other common factors, and no. So that's the same as fraction 35 84ths comes down to 5 12ths. The calculator would confirm that for me. 2 main ways. Here I'm trying to simplify it. I don't want decimals. What's any way of making these whole? Sorry? There's 1 times it by 4. If you notice it, that's the quickest way, because you've got 1 1/4. And whatever denominator you've got, you get any fraction and times by whatever denominator is there, you'll make it whole. 1 1/4. If I get that and times it by 4, well, the 1 times 4 is 4. The quarter times 4 is 1. So it becomes a 5. So that's me just timesing it by 4. 4 4s are 16. And 1.25 to 4 worked out nice. It was 5 to 16. Won't always be that nice. What's another way? If I hadn't noticed that was a quarter, times by 100. So it'll still do it. Okay? In other words, 2 movements on the left. Don't forget to give 2 movements to the right. So it was 4. It's become 400. But then I'd look for common factors, and 25 looks good. Okay? There are 4 25s in 100, so I've got 5 25s there. 4 25s in each of those 400s. All right. We're there again. With this one, when it's got units, you want to convert one to the other. And the truth is it doesn't... You're allowed to convert to... If you convert them both to hours, that's fine. Then you get rid of the word hours. Or convert them both to minutes. I would always recommend converting to the smaller unit. And next week 6, I think, when we get into unit conversion, you're going to do the same. Go to the smaller units. That way you can avoid fractions and decimals as much as possible. So here, between hours and minutes, I'm choosing minutes. Okay? So I need to convert 1.25 hours to minutes. If I had the calculator, I've got times by 60. 60 minutes in an hour, I'll just get 1.25 times 60, and it's out. What's it going to be? 1 1/4 hours. Sorry? Yeah, bring it back to 10. Yeah, you just stuck on extra 10. 75, because, yeah, a quarter of an hour takes how long? A quarter of an hour. It's weird working the base 60, but, yeah, it's 15 minutes. Half an hour is 30, quarter's 15. So the full hour of 60 plus the 15, that's 75. But 1.25 times 60 on the calc is still going to give you 75. So it's a ratio of 75 minutes to 20 minutes. Once we've got the same word, we get rid of them and just cancel the 75 and the 20. And 5s is definitely looking attractive. 4 5s there. 5s into 75. Well, I've got 1 of them and then 2. That's 15. Is 15 to 4 in its simplest form, or can I go further? Yeah, that's finished. 15 to 4. The only common factors there are 1. There's no other common factors. Okay, just want to have a quick side look. What if I had gone the other way? Why am I claiming it would be any harder? 1.25 hours. Be that. 20 minutes. What's 20 minutes? Sorry? Do you need me? Yeah. Someone leave their lunch at home? Oh, okay.
Her name's Dorma. Surname's Dorma. Is she here?
Dorma. Is Dorma here? You're going to admit it if you want. Dorma? No. MCLG 56, is that where she's going to be? So, V105, Maths, Basden. Yeah, I mean, this is Basden, but we don't have a Dorma wanting to show. No, I'm sorry. Okay. Let's put the 10-minute break there. If Dorma's here, your mum's out there. All right, 10-minute break. All right. Are we on? All right, back into it. It's not even a full hour left. Can I check, where's the roll at? It's still making it through. All right, everyone. Back to it. Ready to go again. The last bit I was just about to look at, until then we're looking for Dormer, was, okay, we chose to go minutes. I was just recommending that, look, the smaller units are better. Most of the time you avoid fractions and decimals, so converting to the smaller unit is good. What I was just going to point out was, just say we'd gone against that and kept with 1 1/4 hours, I could write as 1 1/4, or still 1.25, but 20 minutes, well, it's 1/3 of an hour. So it was much easier going 75 to 20 and simplifying it than here I'd have to convert them both to 12ths. Here I'd have to, well, I wouldn't want to use 1/3 as a decimal. You can see it's a lot messier. So it's a very strong recommendation, the smaller units converting to that. Here's, well, another fraction one. We can't avoid it. It's a fraction ratio. We're being asked to give it to its simplest form. And again, we're comparing two fractions with different denominators. We want the same. What's the lowest one denominator here to use? Yeah, we're just going 12. That's it. So here it's like the first one I want to convert to 12ths. The second one I want to convert to 12ths. And it is still like the cross method. This 4 got multiplied by 3. So yeah, it's 3 3s there. This 3 got multiplied by a 4. So it's 2 4s there. So I've got a 9 12ths and an 8 12ths. What would my final answer be for this, though? 9 or 8, yeah. It's 9 of these to 8 of them. And they're the same thing. We don't need them. That is a ratio of 9. So for every 9 of them, you need 8 of them. Good. Oh, there was only one on that page. Fine. This next one, no tricks in it. Always be careful, but it's got 50 reds, 25 greens and 10 blues. This is just to introduce the possibility of 3-part, red to green to blue, was 50 to 25. So the fraction analogy falls down a bit here. You don't have 3, 4, 5, 6-part fractions, but you can still treat it the same way. There's 3 bits. For every 50 of them, you've got 25 of them, 10 of them. Divide everything by 5. You're just looking for a common factor for all of them. 2 5s, 5 5s, 10 5s. Okay? 3-part, 4-part, doesn't matter. Simplify it the same way. Look for common factors and bring them down to the smallest whole numbers you can have. 10 to 5 to 2, simplest form. Another one. What do we got? 3 sides of a triangle. Express the ratio of these 3 sides in simplest form. Straightforward as well. It's 3 parts of a ratio, 12 to 6 to 15. What's my highest common factor here? 3. Yep. 4 of them, 2 of them, 5 of them. The only common factor between a 4, a 2 and a 5 is a 1, and that doesn't help us. So good. 2-part ratios, 3-part ratios, hopefully it's a nice sort of topic. Okay, if 3/4 of a tonne of sand and 1 2/5 tonnes of soil. So I've got sand here, I've got soil, because that's what the question's asking. It wants the ratio of sand to soil. I've got given an order. Sand, soil. 3/4 of a tonne. So I've got the same units, 3/4 to 1 2/5. Not an easy comparison. What do I need to do? Yeah, go improper. Whenever you're trying to compare two things, one's proper or one's just a normal fraction and one's improper, yeah, we really want to get it to improper. So that's 1 times 5 plus the 2. In other words, look at it backwards. 7 divided by 5 There's 1 5 in there and 2 left over. 20, is that the best we can do? Denominator? 5's no good, 10, 15, yeah, 20 is as good as we can go. So common denominator of 20. Look at what I did there. Well, I times by 5, so 3 5s. Look at what I did here. The 5 got times by 4, so 7 4s. So again, remember, same thing top and bottom. And denominator's the same, they can go. Is that the simplest form? 15 to 28. Any common factors? 3 is good for the 15, but you'd want a 27 or 30 for the 28. So 3's not getting there. 5's not doing it. 15's not doing it. We've exhausted all possibilities. So that is, it looks like it can come down, but it can't. And here, until, well, weeks 5 and 6, we don't expect much in the way of knowledge of micro, nano, giga, mega, all that stuff. But milli, yeah. And litres, yeah. Okay? It's everyday enough. 250 mils as a ratio to 1.25 litres. It's not going to be too hard either way, but I'm still going to stick with my tactic. I'm changing to the smaller units, which is mils. Okay? I'm leaving the 250 mils alone. How many mils is 1.25 litres? So just lock in. Hopefully we're aware, but 1 litre, 1,000 mils. Okay? Mil really means, or the milli part of it means 1,000th. Okay? So it just means, yeah, there's 1,000. A milliliter is 1,000th the size of a litre. So, yep, okay. I mean, here, what's the highest common factor here? 250. You can see the 5s, you can see the 25s. Really, yeah. There's one, oh, first I should have said, I've got them both the mils. I don't need units anymore. There's 1 250 sitting there, and there's 5 250 sitting there. 4 in the 1,000, there's one more. The whole thing comes to a ratio of 1 to 5. Done. Yeah, so there's no real tricks. Just get the units the same and simplify like the fraction. Oh, there's no real tricks. Except how many? So the ratio of apples to oranges in a fruit bowl is 5 to 3. A to O. How many oranges are there? Yep. Smart ass. No, it's good. Exactly. I mean, it's a trick question. It's me just going, okay, the gut instinct is, well, there's 3 oranges. And I'm just making the point that, no, a ratio tells you nothing about how many things were going on. I said maybe dark-haired to light-haired people in the crowd were 2 to 1. It doesn't mean there's 3 people. Okay, so just, yeah, note. But the exact answer is exactly as Ryan said. Any multiple of 3. I mean, oh, I'm assuming there's no fractional fruits in there, but I don't know that for a fact. But yeah, maybe there's 10 apples, 6 oranges. Maybe it's 9, 15, 9. Okay, we don't know. Just explain the fact. It's only saying how many compared to the other. Now this, and there's it's in the notes, so he inherited these notes. I'm going to change it. I don't know why we have such a cheery topic for this one. But of all the stats, let's talk about deaths in the age group 15 to 24. Okay, we'll just treat it as numbers. But yeah, I think I might come up with something else different. But it's saying a stat that in 1998, in the 15 to 24 age group, there were 1,871 deaths from a total number of roughly 2.6 million. Okay. So the ratio is of deaths to total was 1871 to that total of 2625152. That's a pretty rough way of looking at it. You can get an idea of the numbers, but if we convert it to a 1 to something format, the way we've done it is saying, I want the left number to be 1. So the way to get the left number to equal 1 is divide by itself. Divide it by 1871, and there we are. Divide the right by 1871. You're not Dormer, are you? No? Okay. Finally came out and admitted it? No. So I just divided each side by that same number. Okay, cheers. If anyone else hasn't signed it, I'll just leave it there. And that comes to 1 to 1,403, a bit of approximation. That's more useful, okay? It gives us a happy stat that 1 in 1,403 people in that year, in that age group, died. But just ignoring the topic, it's more useful. It's a happy stat, yeah. But you can see how it's more useful, okay? I can go, yep, 1 in 1,400, okay. So at times we'll be asked to force that same thing, expressed in the form of 1 to something. And all you're going to do is divide the one that you want to be 1, divide it by itself. 4 to 14, okay, divide by 4. So I'm dividing both by 4, which gives me 1 on this side, and 14 on 4 on this side. 14 on 4, that's the same as 7 on 2, half of 7. 1 to 3.5. Okay. So this isn't the simplest form, it's a different question. Normally we don't want decimals. In its simplest form, it is what it is, as long as you change the left-hand side to a 1. On the next one, I could make them whole numbers first to deal with, or I could just go, no, there's no need. If I just want the left-hand side to be 1, just divide it by itself. Divide both sides by 0.3. 0.3 on 0.3 is a 1. 1.2 or 0.3. Thinking about week 3 material, what did we do to this? To be able to work out a decimal divided by decimal. Times by 10 on 10, yeah. Times top by 10 and bottom by 10. 1.2 on a 0.3 is exactly the same question as 12 on 3. One movement, top and bottom, which is exactly the same as 4. So what looked like a nasty sort of ratio actually came 1 to 4. That's actually the same as if we'd just been asked to put it in its simplest form, it worked out the same. But also look back at the original and see, how did that happen? Yeah, that makes sense. It's saying that the right is 4 times the size of the left. 4 times 0.3 would be a 1.2. Yeah. For every one of them, there was 4 of them. Okay. Here, it's just swapped. Sometimes the area of interest is maybe it's a big thing to a small thing. I just want that small thing to be 1. Fine, no harder. Just pick the side. If I want the right to be 1, divide both sides by the number on the right. Divide both sides by 10. 10 divided by 10 is 1. 15 divided by 10, remember when you divide something by 10, it moves the decimal 1 place smaller. So it becomes 1.5 to 1. And same with this other one, it's just a bit of a decimal test. Well, divide both sides by 0.06. Put that over 0.06. Put that over 0.06. On the right-hand side, I've got the number 1. On the left, I can times by 100. Bottom, times by 100 top. Gives me a 24 and a 6. Just still, yeah, a nice round answer, 4 to 1. Okay, moving on. The final bits is about, using the ratios. This is where you've got to work out more so, what's this question asking? Some of them will be like this. We're finding one quantity when given another. We're given a ratio and say the ratio of, say, cordial to water is this to this. I've got this much cordial, how much water do I need? Or I've got this much water, how much cordial do I need? So we're given the ratio, and we're either given left or right, and we've got to find the other. Okay, the ratio of the length to the width of your palm is approximately 2 length compared to 1 width. If the length of Neil's palm is 18 centimetres, what's the approximate width? Now, we can look at that and say it's saying the length is 2 times the width. Okay, his width must be 9. But the numbers aren't always as pretty. We just want a system to lay down. Length to width was given to us as 2 to 1. There's our ratio. The thing we got given was a length. the length of Neil's palm. So I put that on the left with the lengths. And the question I want answered is what the width is. Now, any way you choose to do this is fine. There's different comparisons. You could say, look, if I halve the 2, halve the left, I get to the right. Okay, so I'll halve the 18 and get to a 9. That method works. If you say, here, so I've got 2 times 9 will give an 18. Therefore, I do 1 times 9, I'll get 9. That's correct too. Okay, there's these comparisons there. All of that's fine. There's one method I've laid out just to be consistent, and this method just helps us a bit later. It might seem, well, see what you think of it. But again, whatever way jumps out to you is fine. What I'm doing is saying that this is 2 parts of a ratio. That's 1 part of a ratio. Later on, I'm going to talk about all 3 parts of a ratio. Okay? But at the moment, the only bit of whole knowledge I've got is that 2 parts of that ratio was equal to 18 centimetres. Okay? I'll include units just to... 2 parts is equivalent to 18 centimetres. Hence, 1 ratio part must be 9 centimetres. And that's all I wanted to know the answer to. For every 2 ratio parts was 18, the width was only 1 ratio part. So that was just a technique of finding the same answer. Let's check that again. Here we've got Sally works as a commercial carpet shampooer. She mixes shampoo with water, so ratio 2 to 25. I'll just write that out. Shampoo 2, water 25. Done. How much water will she mix with 75 mils of shampoo? So I'll put the 75 on the left. Would have been easy if it was on the right. It would just be a times 3 situation. Great. Yeah, it's not. It's on the left. So here, the bit of complete info I've got is 2 parts of this ratio is worth 75. The thing I want to know is, what's 25 parts worth? 2 ratio parts is 75. 1 ratio part, half them, 37 and a half. What the question I want answering is, what's 25 parts worth? So times that by 25. 25 times this number gives us 937.5. So this technique, it's just always going to work. And this one wasn't that pretty. They weren't nice numbers. We had a fraction in the middle. But 2 parts was 75. 1 part was half that. 25 was 25 times that. Let's do it ourselves. A string is cut into portions of ratio 7 to 5. The shorter piece is that. How long is the longer piece? So if we're cutting this ratio, there's always a long piece and a short piece. If I'm thinking, is it 7 to 5 or 5 to 7? I'm thinking 7's the longer bit and 5's the shorter bit. Hopefully that's clear why. The shorter piece is 45 centimetres. Okay, that goes on this side. Now again, if you can see the answer already, great. Can anyone see what the answer will be? Yeah, 7 times 9. So if you can spot that 5 times 9 gives that, so 7 times 9 will give us our answer, you're totally right. Straight for it, lock it in. With the method I've been describing, this is the only complete bit of info I've got. And 5 ratio parts is equal to 45 centimetres. Hence 1 part will be a fifth of that, which is 9. Therefore 7 parts, which I want the answer to, will be 7, 9. Okay? So it was a divide by 5. It was a times by 7. Whichever way, please, Joe. Yeah, 5 parts. Divide 5 times 7, and we're there. All right, let's look at another. As long as I'm not rushing through. Okay, so you can be given 1 part and then ask for the other. Or, dividing a quantity in a given ratio, you're not given 1 part, asked to find the other. Was I too quick off that slide? No? Anyway, sometimes you'll get given the whole thing and be asked, split this into this ratio. And that's where this parts thing that I was writing might help. Sam and Chris invested in a takeaway shop in the ratio 3:2. So for every $3 Sam put in, Chris put in $2. Okay? Remember, it's the order in which it states. The order matters. They made a profit of $40,000 and they're going to share the profit in the same ratio as their investment. So the Sam to Chris ratio was 3:2. And we've got $40,000 to split up. So imagine for every $3 Sam gets, Chris is going to get $2. So just look at there's 3 ratio parts he's going to get and 2 ratio parts he's going to get. It's 5 parts. Get the $40,000 and visualize getting the 40 grand and splitting it up into 5 equal parts. If you make 5 equal parts, Sam will get 3 of them, Chris will get 2 of them, and you've done it. So the whole tactic with these is add up the numbers. We've got 3 parts and 2 parts. I've got 5 parts. Go back to the total. Divide it by the 5 parts. If I split 40 grand up into 5 parts, it'll be $8,000 per part. And then we said Sam's going to get 3 of them and Chris is going to get 2 of them. So Sam gets 3 lots of that and Chris gets 2 lots of that. So my answers are here, but I always do a final check just to make sure they're still adding up to the total. 24,000 and 16,000, it's 40,000. So I think these ones are actually nicer because you don't get the order around the wrong way. It's just it's straight up. Add them. Total. Divide by the sum of them. And also just make sure you're answering what the question was. Again, to make the colour orange, red and yellow paint are mixed. So red and yellow, it's a 2-part ratio. They're mixed to give a total paint of orange. 4:3 respectively, okay. The red and yellow ratio is 4:3. How much red paint is needed to make 140 mils of orange paint? So we've got to lock in that 140 mils is total. Okay, the red and yellow became orange. So the total we're going to split up is 140. How many parts are we going to split up into? 7. 4 parts and 3 parts. We're not really going to split up the paint. Once it's mixed, it's done. But we're working out how many parts went into it. For every 4 reds, there was 3 yellows. So there were 7 parts in making it. We made 140 mils. So 140 divided by the 7 says there was 20 mils per part. So there were 4 parts of red, there's 3 parts of yellow. It was 4 20s and 3 20s. 4 20s says 80 mils of red. 3 20s says 60 mils of orange. 80 and 60, that's 140. For the sake of the question, however, it is only how much red paint is needed. So it's 4 20s, 80 mils of red needed. And for the trivia, 3 lots of 20s, 60 mils of yellow. So it's very much the same. So here's one, and this is overly simplistic, but it's just to show again. 80 people in a room, the ratio of men to women is 5:3. So the first thing I write is my order. Men to women, 5:3. Now, you can already see they add up to 8. It's nice, okay? My total is 80. Each part will be 80 on the sum of these parts, 5 plus 3. It's 80 on 8. It's 10 people in every part. So I'm saying there's 5 parts and each part's worth 10. Saying there are 3 parts and each part's worth 10. So it's good I'll adjust 50 to 30. Is 50 to 30 the same as a ratio of 5:3? Of course it is. Does 50 and 30 add up to 80? Of course it does. So that was, fairly straightforward. Do I have another there? A straight split. What am I going to divide 84 by? 7. Okay, 2 and 5. 7 parts I want. My working would just be basically as much as 84 on 7, which I might go to the side, whatever, but I'd get 12. Oh, we've got the calcs in this. So in other words, every part is worth 12. 2 12s, 5 12s. Before I leave it, I just check. 24 and 60 adds up to 84, the total. And 24 to 60 rounds down, or simplifies down to 2 to 5. There's just expect questions just like this. Okay. The last bit, not that much left. is just a little bit of application of it. And in this, once again, I know we haven't hit the milli, centi, kilo sort of stuff, but we're going to make assumptions that our measurements are okay, that our metric measurements, that we know how many centimetres are in a metre. How many centimetres are in a metre? 100. How many millimetres in a centimetre? Or milli in a centi, not milli in a metre. Just the milli in a centi. 10. So we want to be able to picture them. Just picture the ruler for these. Milli there, centi there. 10 millis make a centi. 10 centis make the metre. The milli, yeah, there's 1,000 millimetres in a metre. What did I say? Did I say 10 centimetres is a metre? Cool. Okay. It's not. Okay. I meant 10 squared. I was being clever. No one saw the squared. It was there. I'll talk less. I've got good slides here. Let's just read them. Scale drawings are a two-dimensional, accurate representation of larger or smaller... Yeah, okay. So in scales and that, we either reduce by 1,000 or maybe we enlarge by 1,000. Here's some words, ratios, fractions. What matters here? The important thing I want off this slide is denoting that versus that. Okay. These things are always going to be written actual, scale, to actual. All right, so the scale measurement, the picture, the drawing, the map, the photo comes first. The real-life object you're describing, viewing, whatever, comes second. So, in this case, the order really matters. So if someone says 1 to 1,000, we're thinking, hang on, is this a reduction or an enlargement? We're looking at a reduction because every 1 centimetre on this picture represents 1,000 centimetres in real life. Okay? So we've taken 1,000 centimetres and we're reducing it down to 1 centimetre. It's definitely been reduced. If we're looking at a picture of that came through a microscope, it's the other way around. Maybe there was 1,000, I'll just put it this way. Maybe there was 1 micrometre we're looking at, which is really tiny, but we've enlarged it so it was 1,000 micrometres, which is 1 millimetre that we can see. So, maps look like this. Okay, microscopic drawings that have been enlarged are in the other order. But it's always going to be clear once we start doing the question. So we do scale to actual. Here's a question. On a map, a distance of 40 metres is shown by 1 centimetre. So it's a fairly large area we're looking at. 40 metres, 1 centimetre. Put them in the right spot. The scale length here is the 1 centimetre. It's been scaled. The real life length was 40 metres. Simplify the ratios, make them the same units. Again, we wanted the same units. I'm going to convert to the smaller. I could convert 1 centimetre to 0.01 or 1/100th of a metre because we all know there's 100 centimetres in a metre. But I'm going to convert metres to centimetres. It's easier. 40 metres will be 40/100 centimetres. In other words, 4,000 centimetres. So I just times by 100, metres to centimetres. Now that I've got the units, I don't need them. 1 to 4,000. The scale of this map was 1 to 4,000. I'm happy, yes, the 1 is on the left. 1 centimetre here represents 4,000 centimetres real life. There's the scale of the map. All good. Do another one. Opposite direction. But it's still scale first, actual second. An actual length of 15 millimetres is shown as a scaled length of 60 centimetres. 60 centimetres, 15 millimetres. The smaller unit is millimetres by a factor of 10. 60 centimetres is 2 rulers. That's 600 millimetres. So a times 10 there. Millimetres are there. They can go now. And 600 to 15, I look for the highest common factor. I could use 5, I could use 15, I might not notice it. So maybe you do the 5s first and the 15s. Either way, you'll get down to 40 to 1. Okay, there are 40 15s in 600, there's 1 15 in 15, and yeah, our scale is 40 to 1. All right, so that's how we find the scale. We just make sure we're in the right, got left and right correct units, done. Here, we're given the scale. So a scale on a map of Australia is 1 to 10 million. Determine the distance from Perth to Sydney if the distance on the map is 40 centimetres. So here's a picture of Australia, and it's 40 centimetres showing between Sydney and Perth. You can already see, if it's 1 to something, it's either 10 million times bigger or smaller. And hopefully you know that the map is 10 million times smaller than Australia, not 10 million times bigger than Australia. So what's really going to happen is 40 centimetres times 10 million. But setting it out this way, scale to actual, 1 to 10 million, and the scale length is 40 centimetres, and we're saying that's equivalent to what? Well, one part of this thing was equal to 40 centimetres. 10 million parts of this thing will equal 10 million times 40. So that's a bit of a long one, but there it is. 40 times that adds another 0, and the 1 becomes a 4. So I've got it to 400 million centimetres. Truth is, if you wrote that in an exam, it said how far is from Sydney to Perth, and you wrote it's 400 million centimetres, you're right, not wrong. Chances are I'll say find it in kilometres, okay? So if we've got to convert, well, centimetres back to metres is a factor of 100. So 2 zeros are gone to convert centimetres to metres. Metres to kilometres, that's a factor of 1,000. 3 zeros are gone. And that's it, 4,000 Ks. All right, so if unsure about centimetres, millimetres, just grab a ruler and just make sure. So it's 4,000 Ks. This one, it's the same thing, but it's the other way around. Scale to actual, 160 to 1. We were given a diagram 40 millimetres long. The diagram is the scaled item, so the 40 goes here. So we're told that 160 parts equals 40. We're saying, what's one part worth? Well, we'd better be dividing by 160. Okay? If 160 ratio parts is equal to 40 millimetres, then one ratio part would be 40 millimetres divided by the 160. I can do a bit of a cancelling there. That's 4 on 16. 4 on 16 is a 1 on 4. A quarter of a millimetre. We're set. Okay, one ratio part's a quarter of a millimetre. Cool. So 2 examples left. Second last one is this, scale model of a car. Let's just do exactly the same. Scale first to actual. 1 to 12. Is the 25 centimetres go on the left or the right? Left. Because the scaled, the model, it's only the model car is 25 centimetres long. It's the thing that's been scaled. The real car is the actual. One part is worth 25 centimetres. 12 parts is worth 12 by 25 centimetres. So I'll just go to the side, do that. 2 5's 10, 2 2's 4, 5, put my naught there, one of them and them. 300 centimetres. Does a 300 centimetre real car sound reasonable? Yeah, 3 metres. Sounds fine to me. Because again, there's going to, look for realistic answers. Last one, same. Scale. Actual. Given that it's 50 to 1, because it's the other way around, 10 centimetres long on the PC monitor is saying that's the scale thing, not the real thing. 10 centimetres. So 50 parts is 10 centimetres long. Then one part, I'd have to get my 10 centimetres and divide it by 50. If I'm getting 10 centimetres and divide by 50, it's a fifth of a centimetre. Okay? A 10 on 50 is the same as a 1 on 5. Or 0.2 of a centimetre, which I could have done just by, once again, I'm just checking. Remember, if you're not sure what a fifth is, you're getting asked, what's a fifth? As a decimal, just do it. 5s into 1 doesn't happen. 5s into 10 goes twice. Yep, 1/5 is 0.2. That's us, done for the day. All right, see you in the tute, or have a good Easter break. So good.